Here's another example of some stuff we did in class, converting grams of a material to particles of a material, particles meaning atoms, molecules, or formula units. If you're watching this, you obviously care about your grade. So here's a suggestion. Read the question, hit pause right now, and try the problem on your own. You've got everything sitting in front of you. You've got your conversion factors. You've got the problem. All you need to do is go through the guess method and then check your steps that you've done against the steps that I'm about to do. So that's my suggestion. Why don't you hit pause right now. All right, welcome back. You're done with the problem, and let's go ahead and give it a try together. Or at least, I'll tell you what, you've already done it. Why don't you check your stuff against mine? So here we go. I'm going to identify my given. So my given is 505 grams of carbon tetrachloride. Here's my given. My unknown is, I want to know how many representative particles. Now we've talked about this in class before. I can't just leave this as representative particles. I need to choose between atoms, molecules, and formula units for this. And we'll do that in a couple of minutes. We'll do that when we need to. I've got my given, my unknown, and I've got my conversion factors. So let's just go ahead and get started on the setup and see where it takes us. My given is 505 grams of carbon tetrachloride. Now, I'm not going to just leave this as carbon tetrachloride. That's a lot to write out. I'm going to go ahead and write the formula for this. So what I'm going to do is, I know that this is molecular already because carbon is a nonmetal, and the other big clue is this prefix here, tetrachloride. Molecular compounds are the only things that use those prefixes. So what I'm going to do is I'm going to write carbon and then chloride, and I know that there's no prefix on this, so it's just one carbon. And that chloride has a prefix of 4, of tetra, which means 4, so I've got CCl4. So it's 505 grams of CCl4 carbon tetrachloride. I'm going to set this up like guess method times. Now I want to get rid of grams, so that means I'm going to use moles and grams from the periodic table. Molar mass. I'm going to use this second conversion factor at this point. So I know I'm going to put grams of carbon tetrachloride on the bottom and 1 mole of carbon tetrachloride on the top. These blanks are my material. My carbon tetrachloride goes in here, carbon tetrachloride goes in here, and I'm going to fill in the molar mass from the periodic table in a second here. So let's go ahead and calculate that. Where can I do this? Where have I got some room? I guess I can do it down here. I've got carbon. I've got one of them, so it's 1 times 12.01, which is equal to 12.01. I've got chloride, which is tetra, so that's 4 of them, times 35 point. Let's go ahead and look this up here. I got that 12.01 from here for carbon. Chlorine's right down here. That's 35.45. So it's 35.45, which is going to be equal to 4 times 35.45. I'm thinking it's around 140. Yep, 141.8. So I've got 141.80. Add these guys up, and I get 153.81. You know what? I'm going to check that because I don't want my number to be wrong. Plus 12.01 to 153.81. That's what I got. Okay. So that goes down here, 153.81 grams. Cancel those units. Grams of carbon tetrachloride leave, and I'm left with moles of carbon tetrachloride. Moles is not representative particles. My representative particles, it's got to be atoms, molecules, or formula units, so I'm going to need to go one more step here. So definitely I want moles to cancel, so moles has to go on the bottom. 1 mole carbon tetrachloride. on the bottom. So these guys will cancel. And then on the top has to be grams of carbon. Nope, I take that back. We already got rid of grams. We are looking for atoms, molecules, or formula units at this point. Well, this guy right here is a non-metal. Non-metal, which means this is a molecular compound, which means I am looking for molecules. So my representative particle, told you we'd figure this out at some point. There it is. Representative particle, I'm looking for molecules. So I'm going to get rid of atoms. I'm going to get rid of formula units. I'm just worried about molecules of carbon tetrachloride. This was 153.81. All right, so that means on top is going to go 6.02 times 10 to the 23rd molecules carbon tetrachloride. At this point, I'm left with molecules. That's what I was looking for. So I can go ahead and grab my calculator and calculate my answer. So I'm going to go multiply it by everything on top. So it's going to be 505 times 6.02. I'm going to use that EE button right there above the comma so that I don't have to worry about parentheses. I don't have to worry about the caret, times 10 raising to some power. That right there is my times 10. So the next thing that comes into play is my exponent. Now I'm going to hit enter here. What that does is it finishes up the calculation on top and I'm ready to divide by whatever's on the bottom. I'm not going to divide by 1. That's not going to change a thing, but I am going to divide by the 153.81. Hit enter, and I get 1.97 and so on. I've got to watch my sig figs here. Let's talk about sig figs. 505 has 3 sig figs. Infinite sig figs here. Let's write this down. I've got 3 sig figs here. I've got infinite sig figs here. I've got 5 sig figs here. I've got 3 sig figs here. Infinite sig figs here. My least number of sig figs is 3. So that answer needs to go to 3 sig figs. So we're looking at 1.976. That 6 is going to get dumped, but that 6 is big enough to make my 7 round up to an 8. So my final answer is going to be 1.98 times 10. Hopefully it's times 10. Yep, there it is. E24. So that E stands for times 10 to the 24th molecules carbon tetrachloride. And I'm done. This was a 2-step problem. It didn't end after that first step because I wasn't at molecules yet. I was at moles, and moles is not the same as molecules. So make sure you're watching where your problem is supposed to end.